Hello guys, welcome to my YouTube channel Scholar Tech Studio. In this video, I will teach you how you can do co-simulation of EDEM software and Adams View. If you will follow all the steps, and I'm going to make a detailed video, then you can do co-simulation for different models. So you just need to watch the complete video. The first step is that from this website we need to download this tutorial that is related to tutorial of screw propeller. Okay, so you just need to download this, and after download I have download this one. Okay, in my compress folder, so I have download and then I have uh, uncompressed the files. So we will open this folder. So from here we just have to select this file and this file. So these three files are very important. Every time when you want to do a co-simulation of Adams and EDM, so you just need these three files. So you can save these three files in your system. So we will use every time these three files for co-simulation. So we will just copy these three files, and then we will paste these three files into our specific folder. I have created a folder Adams and EDM, so I just paste these files here, right? And here you can see that there is a step file that I'm going to use as my model. So you can put your step file or STL file or XRT file in this folder. Okay, so the next step is we need to change the name of these two files. Let's suppose I'm going to build a model in Adams View and I'm going to give the name as rotor. So just right click on it and then go to rename option and select ROTOR, rotor. Right, similarly just change the name of this file ROTOR, rotor. Okay, so I hope you understand from this step. Just copy these files and change the name of these files. Now we are going to open Adams View. Okay, Adams View window will pop up. So we will select a new model, and here we will select the same name that we given to the file, like rotor, and gravity is okay, unit is okay, and also working directory we will select the same folder, right? So we will select the same folder where we have put these three files. So we select the same folder as the working directory of this model, and the model name also must be same as the name of those files, and then said okay. Now we will establish our model. First we will import the step file of our model. So from here we will select the step file. From here we will select our step file, and from here we will select the model name, and here we will guess as a router. So this is our model name, and we just said okay. We will ignore this one. Okay, and from here we can make it 3D solid body. Okay, so these are our model. So basically in this model I'm going to put my bulk material in this one, and the internal part will rotate. Okay, so the first step is we need to change the name. We need to assign the specific name to these bodies. So let's suppose this is my first body. I give the name as a box. So just rename this one as a box. Try to make these names as short as possible because we need to use these names in our configuration files. And this one, let's suppose I just select as a and said okay. So we just change the name, then we will assign the material. Okay, and then we will go to the, let's suppose, steel. Similarly for rotor, we will select the material, select the steel. Okay, so the next step is we need to provide the constraints. So we will go to connectors, we will select the fixed joint, we will select the box, we will select the ground, and then we will specify the location. So we have fixed our this box, and now we need to create a revolute joint. Okay, so we need to create the revolute joint with this part. So we can hide this one external part so that we can easily select the reference point. We will select the revolute joint, then we will select this body, and then we will select the ground, and then we will select the like CM, center of this body, right? But our joint is not accurate, it's in this direction, so it will rotate in, we can say, around the axis, but we want to rotate it around the x-axis. So from the connector, from here we will go to modify, and here we can find option this one, and then from here we will put the value of 90 degree, and we want to rotate this around z-axis. Okay, so we have to select x-axis for rotation, then it will be like rotate around x-axis. So we just select x-axis. Now we can see that the rotation is changed, so now it will rotate like this direction, and then we said okay, and from here is okay, and from here we can use like to show the body, right? Now we need to define the motion. So we will go to motion, and we will assign circular motion, revolute motion. We will select this joint, and from here we can modify this one, and let's suppose this is 100 degree, 100 degree per time. It means that in 1 second it will rotate 100, and 2 seconds it will rotate 200, so it multiple of time. Okay, or we can put it as a 360, then it means that it will rotate one revolution in 1 second, and said okay. Now we can check the performance of our model. Go to simulation, here we will select the 10-second our time, and here we will select, let's suppose, 1000 time steps, and run the simulation. Now you can see that it's working well. So our Adams model is ready. Now we need to export this model, and we need to make correlation with this model and EDM model. So what we will do, we will go to force. This is very important point. Like if you have many parts of your model and you just want to import some parts that you want that will interact with our bulk material. Okay, so we have to do this for only for specific parts that are our important parts, and that we are going to deal with that parts and the bulk material. Okay, let's suppose I want all these two parts. So what you have to do, this is very important step. Here under the force option there is a G force, so we'll select G force, and then we will select the box, and then we will select the ground, and then we will select the box CM. Okay, so we have to select the box CM, so we will select the like the center point of all the bodies that we want to import to Adams EDM. So I select the box center part. So similarly for this part, so I just hide this one. Okay, and now I can easily select the center of this part. We will go to G-force, we will select this body, we will select the ground, and now we will specify the router CM. Okay, so G force is created. Okay, and then we will we can show this one. Okay, so the last step is that we need to modify these G forces. We will go to forces. This is our G force 1. We will go to modify. From here we just select the subroutine. Okay, so we'll select the subroutine. For here we will select the 0, and inside uh, the uh, like inside the model that we downloaded. Okay, so from here we can just copy, or you can just write this one every time when you will do this. So you just need to copy this, or you can just write this one and you can put as a routine, paste. Okay, and that is okay. Similarly we will do for G2. So we will repeat this all the parts. For this one is 0, and this one we will paste that one. Okay, so we'll do this for all the parts that we want to import in EDM software, right? And then said okay. So now we have done all with our Adams view model. So we just need to create the G-force of all the parts that you want to import into EDM, and then you need to modify this one. Then go to file, and then we will go to export, and here we will select the Adams solver dataset and make sure that these names are rotor is okay. So here we just need to uncheck this one, and we need to check this one. This is also very important step, that export all graphics, and we will uncheck this one and just said okay. So now our model is ready. Now we need to create our parallel model in EDM software. So we will open the EDM software, or first we can just save this model, save database. Yes. And now we will go to EDM. We will open our EDM. I'm using the 20 for Adams I have 2020, and for EDM I have 2022.1. First I did the course simulation with 2024 and 2022.1, then it was not successful. Okay, but for 2022 Adams and 2022 EDM it's okay. So now we just open our EDM software. So for here we will go to create. So you can create just bulk material. I'm going to create a default material, so you can create your material according to your requirement. Okay, then we need to create the particle, and for particle I'm going to select this one, and I'm going to select the radius of the particle is 20, is 30, right? So I have, then you can select the size distribution. I'm not going to going to go detail about this, because the purpose of this is to just teach you how you can do the course simulation. Okay, then go to properties and just calculate properties. Now we have done with our bulk material. Now we will go for equipment material, and we will create the interaction between the bulk material and the equipment material. Now we need to import the geometry, so we just right click on it and then go to import, and now you can see that there is a file name router.xmt.txt is created. This file is created because we export some part from Adams, so we will select this one and then go to open this one. For this we will select the CAD units by default, and we just need to click OK. So now you can see that our geometry is imported into EDM software that we exported from the uh, Adams software, right? And here what we have to do, we have to change the names. So this is the outer part, so these name must be same. Okay, so these name must be same so that there will be no problem. So we will give the same name. So this is the box and this is a rotor. So I just give rotor. So we must give to the specific name that we did in, see, that we did in Adams. So we will give a sign, or we will give the same name to in the EDM model, right? Now we need to create a factory. So we will go to geometry, we will add a polygon. From here we will select a virtual, and then we will go for transformation, and here we will select 90° because we want uh, our factory from above side, and from in the y direction we will select 940. Okay, so now you can see that our factory is ready, our virtual surface is ready that we are going to use as a material factory. Now we will select this new body, right click on it, and then we will go to add factory, and here we will specify the material property. So I just select 3000, and here I also select 3000, and here we have to specify the velocity in minus y direction, 3 millimeter per second. Okay, and this is okay. The next thing is environment. So here we can see that the gravitational force should be in minus y direction. Okay, so from here we can check the mesh, so it must be in downward direction, right? So for that, but in this case it's in z direction, so we will copy this one, cut this, and here we will put the value 0, and we will put the value here. Now it's in negative y direction. So our model is almost ready. Then we will go to create option, and we have to save. So we will save this EDM model in the same folder, right, where we have the other files. We can give any specific name and just save. Now our model is ready, and from here we can select the auto time step, and here we can estimate this one, the value of r, and we don't need to change anything here. We just need to save this model, save, right? After that we are going to do the our main part. Okay, so we will go back to our folder. Okay, so the first step is that this is ACF file. We will right click, or we can double click on it, or we can use option edit, open this one. So here you can see that the first a.adm. Okay, so in the file here you can see that we have one ADM file. So this file we will just change the name according to our file, so it must be rotor, right? So every time you have your model, right, this one .adm file that we exported from Adams, so we have to specify the name, right? This is the name, or we just replace this with the rotor, and similarly we will replace this rotor. So take care to put the right value. Okay, so these are the just name. We will replace this name with these 2 points. Now we need to specify the end time. Let I want to run the simulation for 10 seconds, and the time step must be, let's suppose 1000, right? So we just need to make these changes. I hope you clear about this one. We have to give the name as it is, and then here we just put the name router, and here we will specify our simulation parameter, like the total time of simulation, and here is the total steps of simulation. then we just go to file and then go to save. Okay, so the next step is environment variable. We will open this, and here you can see that here is the name of cosim file, right? So here you can find a cosim file. Okay, so we will replace this name as a rotor. Okay, and make sure that it's into it's into brackets, or no, not brackets, in like these I'm not remember the name, so it must be into quotation, right? So it must be in quotations. After changing this name, we just need to copy this one. Okay, just copy this environment, and now we will open this rotor EDEM file. Just right click on it and then go to open with text or notepad, and under the time, here we will put enter, and we will just paste it here. So this is our next point. We don't need to like change anything, we just need to paste it here. Okay, and then go to save and then close. So this is our most important step. The last step of co-simulation, we will open this like cosim file. Just right click on it and then go to open with text or notepad, or okay, open this one. And from here, this is also very important, so you have to take care about this one. If you will learn this point, then you will find that the co-simulation is not difficult, but you must have to learn this point. Okay, we don't need to change from here to here. Okay, this is the Adam processor, and here we put the name Adams, so we just need to change the name of Adam is secure to rotor. Okay, so we will just change the name of the model from here. And then this is also very important point. This is a path. Okay, so it will depend on which version of Atom software you are using. Okay, so what you have to do, we have to find this path and we have to copy this path according to your like the version. So how, from where you can get this path, we just go to the C drive, then program file, then your version, and then common file. Okay, so we just open our C drive. Okay, so we will go to C drive, and then we will go to program file. Under the program file, we will find the MSC software, then go to MSC licensing, not licensing, Adams, and then Adams, and here we will find the common file, and we just copy this one from C to common file. We just copy this one, and then here we can see that we will just replace this one up till to this common file and then paste. So you will do this step according to your system and where you have installed this one. Okay, and the last step is that before the .acf, because we have acf file and we give the name as a rotor. So you just need to make sure the this path and this name, and this is the working directory where you have all the files. So my files are, yeah, this is my folder where I have all the files like EDM file or Adams file or rotor pin or cosim file. I just copy this path and I will replace this path with my current path. Okay, so I hope you clear this point. Okay, so this is very important. This is very important. interaction. So this is the interaction between Adams and between the EDMs. And G-force, you remember we have created G-force. So if you have one port that you have imported from Adams to EDM, right, then we will use this interaction, and if we have more than one, then we will copy this and change. We know that our first part is box, so we will just replace this with our first part name, and similarly we will replace this with the name box, because we have box name in both. Okay, and for G-force ID, you remember that what is G-force ID? This is G-force ID. Box, for box is 1, and for this internal part is 2. So we have to write according to this one. So G-force ID is 1 for box, but we have two parts. If you have more than two parts, what you have to do, just need to go select this, and then we need to control V, paste it here, and we will change the name. Our second part is ROTER, rotor, and we will also replace this for rotor, right? And now our G-force ID for is 2. If you have a third part, so you will do the same, then G-force ID for the third and fourth and so on. Okay, I hope you have clear this point. So the next step is for EDM. So we will just change this name to our model ROTOR, rotor. Okay, and then from here we will change the screw to our box. So our first part name is box, and here we also put the box, and geometry name is also box. And but we have two geometries, so we will just copy this interaction, copy this one, and paste it here. And so, and then our second part is ROTER, rotor, and for here we put ROTER, rotor, right? And for here we also put ROTER, rotor, right? So if we have more than two parts, so we just follow the same steps. Even if we have 10 parts or 100 parts, we will just do the same. Okay, and after doing this, we just need to save this file. Okay, and close this one, right? And after that, we will, from here we have to start coupling. So we have start coupling. Now we will open the Adams co-simulation. Okay, so you have Adams co-simulation, so we just open this one. Okay, and let me change this to mesh, and we have opened the co-simulation file, right? This one, co-simulation file. So here we will select the file option, then we will open configuration file. This is the configuration file that we have created, and then go to open, right? And then just click on atoms. So we can, here we can see that these are the two parts. Okay, interaction, connection, G-force ID, that are the, if you have 10 parts imported from Adams to EDM, then the list will be here. You also need to specify that is your path of this is okay, is accurate. Okay, so the path of this is accurate, and the name, and similarly directory path is accurate. After that, we just need to click on run and okay. And now it says that the core simulation is started, so we can open our EDM software. Okay, we'll click on the update, and now you can see that our core simulation is working. We are going to control our core this core simulation from the EDM, and You can see that this is also rotating and our material is also going to deal with them. If we will select from Z, yeah, from here we can observe that our bulk material is adding and our part is rotating. So in this way you can do the core simulation. If you have clear all the steps, then you can use this for all type of core simulation of ADEM and EDM. So here you can see that this one is rotating. See, this one is rotating, and we are controlling the rotation of this from the EDM software, and our bulk material is also going to add. I hope you like my video. Please subscribe my YouTube channel and press the bell icon so that you can get the notification of my upcoming video.